Hi everyone. Today we are going to discuss about transistor switching characteristics. So what is transistor? Transistor is a three-terminal device which has two junctions and which is operated in three regions. So whenever the two junctions are forward biased, then that region is called as saturation region. When these two junctions are for reverse bias, then that is known as cutoff region. When one junction is forward bias and one junction is reverse bias, then that region is known as active region. So whenever transistor is in cutoff region, it is acts as a off switch since it is open circuit. Whenever it is in the saturation region, it is acts as a on switch, that is closed circuit. So whenever our transistor is either in cutoff or saturation, it is acts as a switch. That means when it changes from cutoff to saturation or saturation to cutoff with a negligible active region is known as switch. That's why we can say that the transistor is acts as a switch. It is one of the application of transistor. So when you see the transistor circuit here, so whenever some input is applied through a base resistor, if that input is less than that of saturation VB, that means VB is sat, that value is 0.3 for zero point 0.7 for silicon and zero point 0.3 for germanium. If it is less than that of VB sat, then our transistor is acts as an open circuit and it is acts as a open switch. So when it is greater than that of VBE, then it is acts as a closed switch and it is in which position? On position. So according to VBE sat, we can get the collector current. The collector current we can calculate by using the formula VCC minus VCE by RC. So now we have to see that how our collector current has been changed according to the given input voltage. Let us assume that when some pulse input is given to our transistor, the pulse is a short duration step. So whenever in the pulse, if input is rises from zero, that is the zero level to some maximum value, our transistor actually should be change into its state from to the saturation, but the collector current is not increases or not in the response immediately due to the junction capacitance. Due to the junction capacitance, the collector current exponentially increases from 0 to some maximum value. So that's why we can get some delay time. That time is called the time required to raise your collector current from making 0 to 10% of its maximum value is known as delay time. Since the collector current is increases exponentially we can calculate or we can determine the rise time. Rise time is defined as the time required to raise our collector current from 10% to 90% of its maximum value is known as DR. The rise time. The sum of delay time and rise time is called as a transistor on time. So the collector current is maintained same constant until so the change of input voltage is transition from maximum value to minimum value. At the time when input voltage is changes from its maximum value to minimum value, the collector current does not fall down because due to the same region junction capacitance or some minority carriers are there in saturation. So whenever those minority carriers are vanish, then only the collector current is decreases. That's why the storage time is happens. What the storage time is the time required to wash out the minority carriers in saturation region. So the time required to decrease from maximum value to 90% of its value is known as storage time, and the fall time is follows. Fall time is defined as the time required to the collector current which is fall from 90% of its maximum value to 10% of its. That the sum of this storage time and fall time is known as turn off time. So these are the characteristics of switching characteristics of transistor. So again, once again, we will define our switching times. Actually, we have four switching times. One is delay time, next one is rise time, storage time, fall time. So what is delay time? It is the time taken to attain 10% of its maximum value is called as delay time. Storage time or raise time. Raise time is required for the output current IC from 10% to 90% of its maximum value. So this is called as a raise time. The sum of these two time is known as turn on time or transistor on time. Storage time is a time it is equal to sum of time taken to removing excess charge stored and the time taken by the collector transition capacitance to discharge to 90% of its maximum, but major portion of time is taken in removing excess charge stored. So this is called as a fall time. So fall time. The sum of the storage time and fall time is known as off time. So this is about how our transistor is acts as a switch. All these times are known as switching times of transistor. So whenever our transistor is switches from on cutoff region to saturation or off to on or on to off, the time required is nanoseconds. Then only our transistor switches fastly, so that the time required to access our transistor as a switch means that is nothing but nanoseconds. So this is about how our transistor is acts as a switch, and what are the switching times of transistor. Thank you. All the best.